Hi, welcome to my channel. In this video, we want to solve the following problem. In isosceles triangle ABC, AB equals AC. Point D lies on AC such that BD bisects angle ABC and BC equals BD plus AD. If we denote angles ABD and DBC as theta and angle BCA as 2 theta, the goal is to find theta. And now for the solution. First, let BD equals X, AD equals Y, and DC equals Z. Since AB equals AC, we have AB equals Y plus Z. Also, since BC equals BD plus AD, we have BC equals X plus Y. By the triangle inequality, in triangle ABD, we have X plus Y is greater than Y plus Z. In any triangle, the larger side is opposite the larger angle, and so, in triangle ABC, angle A is greater than 2 theta. Using the angle sum property, we have 180 degrees equals angle A plus theta plus 2 theta, which equals angle A plus 4 theta. Because angle A is greater than 2 theta, it follows that 6 theta is less than 180 degrees. Next, extend BA to a point P such that angle ACP equals 2 theta. Such a construction is possible since 6 theta is less than 180 degrees. Next, join D to P. Construct DQ perpendicular to PB at Q. Construct DR perpendicular to BC at R. And construct DS perpendicular to CP at S. Next, consider triangle BDQ and triangle BDR. We claim that triangle BDQ is congruent to triangle BDR. Since angle QBD equals angle RBD equals theta, angle DQB equals angle DRB equals 90 degrees, and BD is common to both triangles. The two triangles are congruent by AAS. Since DQ and DR are corresponding sides in congruent triangles, we have DQ equals DR. Next, consider triangle DRC and triangle DSC. We claim that triangle DRC is congruent to triangle DSC. Since angle RCD equals angle SCD equals 2 theta, angle DRC equals angle DSC equals 90 degrees, and CD is common to both triangles. The two triangles are congruent by AAS. Since DS and DR are corresponding sides in congruent triangles, we have DS equals DR. Next, consider triangle DPQ and triangle DPS. We claim that triangle DPQ is congruent to triangle DPS. Since angle PQD equals angle PSD equals 90 degrees, DQ equals DS, and DP is common to both triangles. The two triangles are congruent by HL. Since angle DPQ and angle DPS are corresponding angles in congruent triangles, we have angle DPQ equals angle DPS. Experienced viewers may recognize that D is the incenter of triangle PBC, and that the previous steps are to show that the angle bisectors of a triangle meet at the incenter. Returning to our solution, let us consider angle PAC, which is an exterior angle of triangle ABC. Since an exterior angle equals the sum of interior opposite angles, angle PAC equals theta plus 2 theta, which equals 4 theta. Next, let T be a point on CP such that PA equals PT. Join D to T and then consider triangle DPT and triangle DPA. We claim that triangle DPT is congruent to triangle DPA. Since PT equals PA, angle DPT equals angle DPA, and DP is common to both triangles. The two triangles are congruent by SAS. Since DT and DA are corresponding sides in congruent triangles, we have DT equals DA equals Y. Similarly, angles PTD and PAD are corresponding angles in congruent triangles. Therefore, we have angle PTD equals angle PAD equals 4 theta. Next, extend BD to meet CP at M. Denote the length of DM as A, and then consider triangle MDT and triangle MBC along with segment MP. Since angle BCM equals 2 theta plus 2 theta, which equals 4 theta, we claim that triangle MDT is similar to triangle MBC. Since angle DTM equals angle BCM equals 4 theta, and this angle is common to both triangles, the two triangles are similar by AA. Since corresponding sides in similar triangles are proportional, we have MD over MB equals DT over BC, or A over S plus A equals Y over S plus Y. Cross multiplying gives AX plus AY equals XY plus AY. Cancelling AY yields AX equals XY. Dividing both sides by X, we thus obtain A equals Y. Since angle BMP is an exterior angle of triangle MBC, angle BMP equals theta plus 4 theta, which equals 5 theta. Finally, consider triangle MDT and segment MP. Since DM equals DT equals Y, triangle MDT is isosceles. Since the base angles of an isosceles triangle are equal, we have angle DTM equals angle TMD. Since angle TMD equals 180 degrees minus 5 theta, we get 4 theta equals 180 degrees minus 5 theta, and so 9 theta equals 180 degrees. Therefore, theta equals 20 degrees is the solution to our problem. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.